A very cheerful good afternoon, everyone. So, we are in today's session, we are trying to solve all this question that was based on graph data structure. Okay, so we see the patterns which mostly followed by many interviewers that are like BFS, TFS, topological sorting, shortest path in a graph, and union find cycle detection, connected component or not, or multi-source BFS is also a 3-star rated, so it can be also be asked by some like interviews. Minimum spanning tree, B's and Floyd Warcel and the connected component. So these are like the like a roadmap or like a cheat sheet for cracking any like question, any graph data structure problems. So let's see one by one and understand the logic. And I know that everyone can code, but we have to understand what the basic understanding of that question, how you figure out that why I use graph in this concept. Okay, the first question that comes here is that like this question, that is number of islands. This one is like starting question. This one is the starting question, and it is a like foundation for understanding the graph concept. So in which I use DFS and BFS to count the number of connected component in a grid. Okay, and what to say like make mark visitors say like explore all the dikes and repeat for each unseen islands, and it's happen in the order of M and N. So let's see the question, understand the logic, and solve this one. Okay. Okay. The first question is that, so first question is that like what do you call number of island islands. Okay. So this question contain like is the one of the most important question for the solving these BFS and DFS. Okay. The question is, in this the problem we have like a grid and having this grid. Okay, so okay, so in this we have a grid and grid one represent grid of the value of one represent land and zero represent the water and count the number of island. So we are having this question. So this graph, this is we are given with these things. Okay, in this 1 0 1 0 1 1 1 1, okay, 0 0 1 0 0. Okay, so 1 is represented as a, so our target is to finish finish this question in like how many minutes. So where the what is the time, like we are actually at 4 minutes and we try to solve in like 10 minutes. Okay, so we have to do this. So we know that this one represented as a land and 0 is represented as a water, and we have to count the number of island. So we can say this is a land, so this mean that this part is an island part. So how can we use, so if we use this one, so this part is a land. Okay, and this part is also a land, and rest of the part that is water. So these two parts, okay, these part are the water. So we understand this, we understand this thing that is that only one and two island are there. So our answer is that two. So how can we find, okay, so in that if we starting from this position, if we starting from this position like 0 comma 0, so if we starting from this position we can go in this direction, right side, left side, okay, like down and up. Okay, so these are the movement we can take. So all islands are like, all islands are connected. So if we go in this direction, that will be like 1 for me. Okay, and the island 1. So if we are in this position, we can go not in this side because there is water, so we can go down again. We have the fourth direction choices, so we can go in direction low, bottom, left side, right side. So go in the right side, and again we see. So if we want to explore all this area, so we see that this is like water, so we can't go here, and again we have to change at this position. So we have to like changes, we see the changes or number of connected component, then from which we can find this answer. Okay, so treat each land as a cell and a node. So like we are like standing at 0 comma, we are standing at 0 comma 0. So these are like treated as a like a cell. Okay, so how many connected component exist? The main question is that how many connected component exist. Okay, so how many connected component exist? So this is like final, this is our final goal. What do we have to explain? Like how many connected component are there? Okay, so we have to like what we have to do. So first intuition comes in our mind whenever we are exploring level wise. So when we explore level wise, so in that case we have to use, so we are using like level wise, this direction, go this way, this way. So in that case we use BFS. Okay, we use BFS. Okay, so let's start with the BFS. So BFS, and increment the island count and start BFS. Visit all the connected cell and mark them as visited, and repeat in entire grid. Okay, so step by step. So first of all, we are at the first position. So I think we have to like erase this part. Okay, okay. So we are starting at the this first position. Okay, first position 0 comma 0 cell, and we have the movement choices. We found the island, so we count as a 1 and run BFS still. So we reach to this position. Okay, we reach to this position. Okay, so entire the first cell is covered. Okay, then continue scanning and continue scanning if any of this, if continue scanning if anything is occur. Okay, so we find we find another island. Okay, so company like explore water. Again, we reach to this position in BFS. So if we find land, so increment the count to 2 and explore the rest of this area is connected to this one. So it cover only 2 places, and we have to just the BFS cover all itself and it return the value 2. Okay, so we understand all the like BFS visualization. So what we have to do, we for the BFS, for the BFS, we know that we can use we can use you use like queue data structure. Okay, what are the approaches that I use here? So for this one, so so what we have to do, first of all, mm, we have to push push 0 comma 0. Okay, and then pop. Okay, what 0 comma 0. After that, push if land is occur, if any of this land is occur, so at like 0 comma 1. Okay, similarly 0 comma 0 comma 1 at this position is 0 comma 1, like is it, sorry, 1 comma 0, 1 comma 0, 1 comma 0. Okay, so push pop, and till we do like island completely explode, and we can do this by island fully explode. And so this is like what we fill inside the grid queue. So what about the direction? You are using movement direction. So what think about the direction array? Okay, what about the direction array? Okay, so direction array. So when we're talking about a direction array, so what we have to do, first of all, we know that we can move in 4 direction. So like we can use like we can use mm, so we can use a array so for the x direction and y direction. So in that case, so we can write as a integer for uh, for the movement of the rows. So we have 4. Okay, so these direction are like -1 comma -1 1 0 comma 0. So this is like movement in the row. If we write int for the column, so we can write as a 4. Okay, we know different direction, 0 comma 0 -1 or 1. Okay, so these are the clear. So because we can move in all 4 direction. Okay, and the loop every time we are in the loop we are using that every time we are incrementing or changing the directions for that one we have to like write in C++ we write for the for loop, so integer that k is equal to I less than, we have 4 direction only, so like till 4 k plus plus. Okay, and so the new area will be, so integer new row is equal to r plus for the dr direction of this k value. Okay, and the new column will be, and the new column will be like column plus direction in column. So it's explore all the possible values. Okay, so it explore all the possible values. Okay, okay, so we understand. We run the DFS if whenever we find increment 1 and run fully, and if we see water, and again we have seen the like island things, so we increment the count. Okay, so I have to write like full code. So like so okay, I'm writing the full code for this one. Okay, so we see here I'm writing, so like full code. Okay, okay, so full code for this one. So first of all, we know that how we find like integer m is for like finding the grid size. Okay, grid dot size. Okay, and integer n is equal to grid of 0 dot size. Okay, so by this one we can find the rows and column, and after that we have like these 4 direction. So we use in at this place we initialize all this 4 direction. Okay, after that we have to like take the integer count for this, how many islands we have. So in that case we have to initialize this one, island count, island count. Okay, so we initialize with this 0. Okay, and after that we then run the loop. We have to like movement for the like traversing the things on the traversing on this grid. So for that one we have to like use two for loop. So integer I, like row we are moving, so I is equal to 0 to I less than on n. Okay, not n, this is m, or I plus plus. And for the movement on these columns, so integer j is equal to 0 starting from, and j is less than n or j plus plus. So this is how we move on the like matrix. Okay, so if I find any grid value of I or j is equal to 1, so we understand this value is a land. So in that case I have to increment this island count plus plus. Okay, so we incremented the island count, and in that case we have to initialize the queue data structure, which is in the pair. The pair mean that we have to like queue integer comma integer. So in that case we know the queue. So in queue we like integer comma integer, that's a row and column. So we push that row column which are showing that it is a, and this is a land. So that queue dot push. Okay, so I comma j. Okay, so pair inside push and okay, and grid mark as a grid of mark as a 0, okay, because we visited that position. The grid of I j is equal to 0, okay. Then after we have to like do BFS on this Q. So what we have pushed inside, so this is like a marking thing, okay. So for that we have to like move on this on Q. So till Q dot empty empty. Okay, so like first of all, we have to extract that value. In extract that value, what are the like value or putting here? So in that case, we use auto, that are rows and columns are given there. So inside the q dot front, q dot front. If you find, so how many minutes are left? So I think we spent like 1 minute. So leave it. So we find this one, and then we pop this value. So pop. After that we have to change the direction that are written here. So that thing is written here. We are exploring all the direction if we find. And during this process we have to like check the valid cases. So if our new row is greater than is equal to 0, and new row is less than is equal to m, okay. And one more thing, and new column is greater than is equal to 0, and new column is less than is equal to, and also check for this, it is length with valid length. So like grid of I and new row and new column is equal to this one value. So that is depicting the line. In that case, what we have to do, in that case we have to mark that grid as a visited. So mark that grid as a visited. So new column is equal to 0, okay, 0 and 0, and push that value into the queue. Push that value and new row and new column, okay. And finally, after doing all this step, and at the end we have to return the island count. So island count, okay. This is like simple steps. So these are the simple step. We see that we are like checking the rows and column, initializing the rows and column. We are like initializing all 4 direction, okay. Running the loop on this matrix, increment count, using the BFS like queue for putting the values inside the queue, and checking all new direction, or also checking the valid condition. If it is valid, so push inside the queue, and this loop run until it become empty. And finally we have to return this island. This is all about what is inside the island count, okay. Note the code, okay. So so we can expect some follow-up question on this one. So we can expect some follow-up question. So the questions are as follows. So we can say that maybe someone may ask like this variation on this question. Someone may ask like what is the size of island. So we have to return like in this one, size of island is 3 and 3 comma 1. So in that case, in the maximum size of this island, or like size of this island, or the maximum size of this island is 3. Another question, okay. And may ask, so these are the like, this is the pit this is a pattern where we understand this is the pattern we understand. So this is a pattern where we understand that like connected component, connected component, connected component, where I use BFS, okay, and also understand what is the starting point of the start of the BFS, how we start the BFS, and how we increment, how we maintain this count plus plus. Okay, so these are the learnings from this. Okay, these are the learning from this question. Okay, learning part from this question. Okay, so we move to the next question that is about so this part is completed. Okay, so like detect the cycle in a directed graph. Okay, so how I detect the cycle in directed graph? Okay, so this is another variation, detect the cycle in the directed graph. Okay, when the question is about to find like detect the cycle in the graph, so what you have to do, so align. Okay, so the question is that uh, detect cycle in graph. Okay, so detect cycle in graph is like most common question. So how can we find the graph? Okay, how can we find that uh, graphs, all this thing? So like this is the most important graph question because it like connected to the service dependency, like all this thing connected. So okay, so let's start the key idea. The first method is that the key idea is that in the directed graph, a cycle exists if DFS can reach the node that is already visited. Okay, it will only possible. So if we have a node, okay, if we have this node, another node, okay, another node. This is the this is like cycle, and this is another node. So if we start from this position, mark as a true. If we start go true and depth, if we choose, okay, and true and came back. Okay, if we start from this position and choose the left side and mark as a true all the sides, so if we choose right side, so we will mark as a true, and we see that this part is already visited. This means that there must be a cycle inside this graph. Okay, so this is the basic concept for this one. So no need to like think that much for, or no need to that much of explanation to solve this question. The first idea came in our mind is that in a directed graph, a cycle exists if during the DFS you can reach the node that is already in the current graph. So for that one, so that one we have to make a visited of nodes. Okay, and the path visited path visited for the node. So these two things we have to keep in our mind. So we need two array. Okay, so what is the path visited? That track the node current in recursion stack. Okay, okay, like if all is visited, so all node are on the current path. Okay, so example without cycle and without cycle and after cycle. So we can use we can use recursion and the stack to solve this problem. Okay, so here is a code for this thing. So first of all, we know that like what we have to do. First of all, we make a vector for this visited one. So like vector of integer, a vector of integer. that we call visited, and besides a v comma 0. Okay, and the vector for this one, this again node, is the path visited, path with. Okay, it is also like v comma 0. Okay, and we have to check if it is not visited, then run this DFS loop. For this one, for loop int I0 I less than v. Okay, I plus plus. Okay, and if, okay, so if we so we can set if not visited, if not visited of I. So this means this thing is not visited. So in that case, what we have to do in this case, if, and if it's not true, if this one is true, so we can place all this in a visited node and this path with. Okay, all inside this one, and if it true, then if it true, then return true. Okay, okay, otherwise return false. Okay, so this thing we have to keep in our mind. So first of all, when we are going to check this code, so first of all we have to mark the visited node. First of all, we have to mark the visited node that we are going, this is equal to 1, and then again this path visited node, path is also as a 1. Okay, so if we find and we run those the earlier the generic code for this one. So for the auto, that what we have to find the neighbor, that is what, that is like adjacency table, and we have to find the adjacency table node. Okay, adjacency table nodes we have. Okay, then if our, if we check if not visited, what if our neighbor is not visited. Okay, if our neighbor is not visited, so this run this run this DFS loop. Okay, so if DFS of all this thing, DFS of all this values that we write here. Okay, and if it is correct, so in that case we have to return true. Okay, else if, and in else if we also have to check, else we have also check for this one, this and the path visited for that neighbor is true or not. If true, to return true. If it all return true. Okay, if all return true, undo this step, undo this step, path visited is equal to that and that node as a 0, and return false. Okay, and return false. So this is what we have to like, and this what we have to look and do. Okay, so first of all we have to write this code at the main function, and then we make visited, path visited, checking the neighbors. If it not visited, this if check the condition for this and DFS and return true. Else if the path is not visited, if path is visited for the neighbor one, then return true. Otherwise make it 0, and backtrack and return false. So these two questions are the important for this one. Okay, these are the important questions that we explored. So another is a topo sort question. So topo sorting. So like, so topo sorting is a like Kahn's algorithm or the like BFS. The topological sorting is one of the most important graph topics. So like in this what we call, okay. So we have to see the graph of this one. So like topological sorting is mean that a linear ordering of the vertices such as we have linear ordering mean that we have to erase this one. Limit. Okay. So for the topo sorting, we know that the linear ordering is important. So if we write u to v, this means that u appear before v. U appear before v. So this is known as the like this one, and it only possible for the directed acyclic graph topological sorting. Okay, directly acyclic graph, and not possible for the any of the cyclic graph. Okay. Okay, so if it like graph is connected to 1 and this 0 is connected to 2, okay, and this 1 is connected to 3, okay, and this 2 is connected to 3, okay, and 2 is 1 is connected to 2 and 2 is connected to 3. So this is not a cyclic graph, we can see that. And for this one, what is a topological sorting? So we can write like 0 is come before and all these two things, so we can write 0, okay, and again we can write either 1 or 2, so I can write 1, okay, and after that like 2 come before 3, so we write 2 here and then 3. So this is the one of the topological sorting. And if we write 2 before this one, like 2 0 and like 1 before 3, so 1 and 3, so this is the topological sorting for this one. Okay, so there's like these are the valid one. Okay, what become invalid? So if I try to write like 1 before 0 and 2 and then 3, so this one is wrong one. Okay, and first of all, like in real world thing, in the real world example, we can say that if we build any system, like compile the utils, then compile the API, run the test and deploy it. So these are like dependency orders, so it will follow some linear ordering things. Okay, and when the question about the course scheduling things, like course scheduling, so we can take math. In course if we do math before DSA, and if we solve DSA before graph, and if you know the graph, then we have to know advanced algorithm. So this is the linear ordering, so we can write like math, DSA, graph, and the advanced algorithm. So this is the like topological sorting. Okay, same in the like data microservices, we have databases, authentication service, and API gateway, and the front end. Okay, like two approaches for solving this topological sorting. So we have two approaches. So we have like first of all the Kahn's algorithm, Kahn's algo, in which that we use BFS. Okay, most asked question in this interview, and another one is like DFS based. Okay, so Kahn's algorithm and both take same time complexity. So let's discuss the Kahn's algorithm. So let's discuss the Kahn's algorithm. So in this case, find a node with in degree. So in that Kahn's algorithm, we talk about the all this in degree and out degree things. Okay. So in degree, we understand that the nodes like this is coming, this means in degree, or this is going, this is the out degree. Okay. Okay. So these are executed immediately. So first of all, we have to calculate the in degrees of all these nodes. So if we like circle this one, this is node, this is node, and this is node, and this is node. Okay. So when we have to like find the in degree of this one, so what we have to like, so the in degree of this one is 0 and the 0, and in degree of this one is like 1, in degree of this one is 1, in degree of this one is 2. Okay, so by this one we can find. Okay, 0 1 and 1, and push or push the element if the in degree is 0. So push the element in degree is 0. So if we push that element, if we push that if we push this element, so if we push this element, so the in degree become also 0. Okay, so in degree become 0 for this one. Okay, in degree become 0 for this one. Again, so we can push the any value. So if we push this value, this value is decremented by the 1 value. Okay, so we can write 1. here. So this is the this is the concept. We push that in degree 0 and push that node, and this is the what answer, and reduce the neighbors, reduce the in degree of the neighbor to 0. Okay, and do this at the end of this step. Okay, so first of all, what are the code for this one? So the code for this one, so I have to write the code for this one. So first of all, we have make the vector, okay, integer in degree, okay, degree size. We have know that the VS size all have initialized with the 0. Okay, and for int we know that u is equal to 0, I less than u less than v number of like that element, and u plus plus. Okay, and if we check, so what I check, and for v is equal to auto or what, adjacency matrix of u. Okay, adjacency matrix of u 1 or 2, all these things. Okay, and increment the degree of that value is equal to degree is equal to for the v plus plus. So we like make the degree of all this thing, and after we like initialize the q. Okay, okay, so what we do in the queue, so what we are doing in the queue. So let's see, don't write I'm not writing the whole code, so we understand logic. Okay, for that thing I think I have to like extract the integrity code. So we can see that the integrity code here. Okay, okay, so we are like this is integrity code. So first of all we have we have calculated this whole things. Okay, and for auto we calculate. So in that case the integrity table is filled by, so integrity table is filled by, if a 0 have a 0 integrity, 1 have 1 integrity, 1 2 have also 1 degree, and the plus 2 value have 2 integrity. So okay, so initialize the queue. Okay, initialize the queue for this one, and push that 0 push if any having the 0 value. So if for auto I starting like we have to traveling on this one. Okay, if in degree of any of the value in 0, so we can push into the queue. Okay, so in that case 0 is pushed inside the queue, that integer. Okay, and we have to like topo sorting. For the topo sorting we have to make another another table. Okay, so we can extract this front value. Okay, 0, pop it, so I pop it, and this value is pushed into the topo sort. So I put that value into topo sort, so we write as 0. Okay, after that topo sort is put, and we have to check the neighbor of this one. So like what are the neighbor of this one at adjacency matrix for this node. So first of all we decremented the degree. Okay, okay, and if you find that value of neighbor becomes 0, so in that case I put the value inside this topo sort, inside this queue. So if the and push the value into the queue, again this loop comes where the front of this one. So we go and extract this value, push this value, and check the neighbor and push into the queue, and this loop continue, and we can find this topo sort for this one. Okay, this is the easiest this is easy, and like we understand what is Kahn's algorithm. Okay, so okay, so we covered 3 questions in approx 40 minutes of session. So like solving that question with the full explanation in 40 minutes. So each question take approx 30 minutes full explanation and the full code. So that's great. That's great approach. We understand like number of island and another like cycle in a graph. Okay, and this topological sorting. Okay, so in next session we try to cover most of that question. So we cover all the 10 question and then we move to different data structure. Okay, thank you for joining this session.